Hello, Mike here, and in this video we're going to take a look at the terminology of machine learning. We're going to go all the way from artificial intelligence all the way through to GPT-3. We're going to link everything together and explain briefly what each of the things are. So let's start with artificial intelligence, and it's an unfortunate place to start because it doesn't actually have a definition, or not an official one anyway. To me, what artificial intelligence means is essentially a future goal, the thing over the horizon, the thing that we're continually chasing, where we want to make machines intelligent. Will it ever happen? Maybe not, but we keep pushing forward with machine learning. Machine learning is very well understood and is very well defined, and I've actually got an entire video about this very topic, so you should probably go and watch that. But essentially, it's computer code that does statistical analysis over lots and lots of data, looks for patterns, and then helps us to understand other data in the future. Now, inside of machine learning, we have another subject, which is deep learning. This deep learning, it's a type of machine learning, but it uses a very particular kind of code, which basically mimics the organic brain, the human brain. This code that mimics that brain is called an artificial neural network. And inside of the artificial neural network, we have artificial neurons and layers and links, and there's a whole world in there that we don't really have time to get into. Now, that code that's inside of machine learning and inside of deep learning to create those artificial neural networks, these are called algorithms. And these algorithms are the thing that actually does that statistical analysis. Now, we have lots and lots of data in the world, and when we take lots and lots of data, we make training data out of it, we put it into our algorithm, and through that training process, we create a model, a machine learning model. And that could come from either machine learning or from deep learning. We end up with that trained model, and that model can help us make sense out of new data. And when we do that, when we present it with something new and ask it a question, essentially, to classify something, that's making a prediction or making inference. Now, when we're doing that inference or when we're doing that training, there's lots of ways that we can look at that process and analyze how well it's performing. And there's a whole world of terminology in there. We're not going to have time to get into that. So let's go back up to algorithm. Now, how do we make these algorithms? Well, it turns out that it's actually quite complicated. There's quite a lot of code, and there's quite a lot of standard code. Standard things that we do all the time to create these algorithms and to create the training processes and everything else that's around machine learning. So to make this job easier, we use frameworks. Now, you might have heard of some of these frameworks already. So we've got TensorFlow, MXNet, PyTorch, we've got scikit-learn. We've got many others as well. But the job of these frameworks is to make it easier for us to write code to do machine learning. But it turns out that even that's actually quite hard. And so there are some frameworks on top of the frameworks that abstract us away further. So you might have heard of things like Gluon for MXNet or Keras for TensorFlow that basically makes the job of creating that code even easier. But it turns out, even then, that actually figuring out how to design something like some of these artificial neural networks takes a long time and is actually quite complicated. And people have done it already. So you can get and take pre-built artificial neural networks for particular jobs. So for example, if you wanted to do image classification or object detection, then you could use something like the RestNet algorithm or a VGG, and there are others as well. These are networks, these are algorithms that have been well understood and well studied by academic research and have come out with these very complicated designs. We don't have to necessarily know about them. We can just take them and start to use them. And each of the frameworks have something in there where you can actually go and get pre-built algorithms to go and do those common jobs. Now, on top of that, imagine that we have to train a network from scratch. Well, that might not sound so bad. We've got lots of data after all, but it can take a very, very long time to train these algorithms up. That's because they're essentially completely empty when we first start with them. So a much quicker way to be able to train models is with transfer learning, where we actually start off with a model, not an algorithm, a model which has already got some understanding of the world and of data, and then we can make it specifically know about our particular subject by doing a little bit of extra training on the top. This is called transfer learning. So at this point, we're doing pretty well. We've got our algorithm, we've got it trained pretty quickly. Where do we go next? Well, we can go to the other algorithms in the world which now sort of transcend even these frameworks. And this is where we're talking about things like YOLO. Yes, that's actually the name of one of these frameworks. Or Hugging Face. Yes, that's also the name of basically a pre-built project which is specializing in a particular area of machine learning. YOLO for image detection, Hugging Face for natural language processing, of course. And that takes us on to GPT-3. GPT-3 is one of the biggest pre-trained models that exists on the planet today, as far as I'm aware, and it is an immense collection of natural language ability. So you can just put in a few words and it can write a book for you. So there we go, really quickly, all the way from artificial intelligence, all the way through to GPT-3 and everything in between. I hope that helped somewhat into sort of placing some of the terminology of machine learning into an overall mind map, I guess, of this subject. Machine learning is an enormous subject, and you shouldn't beat yourself up because you don't know about all of it. Nobody knows about all of it. Just take the piece you're interested in, have a go with it, build some project on it, and have fun with it. I hope you found this video useful. If you have, then please let me know by giving me a like and add a comment below if you've got any questions. Thank you so much for watching, and I'll see you next time.